Hello, my warriors. Welcome to the next session number 3 of magnetic sources and effects. And tonight we are going to discuss how a magnetic field can affect a charge and also the Lorentz force. Welcome aboard. This is Shreyas, your physics master teacher at Vedantu. Hi, Sai Telugu, Code Setup, Dhanush, Unknown, Krish, Priyanka, and our paparazzo is also here. Hi, Vikram. Good evening. Yes, nice to see all of you out here. Hello Jay, hello Surya. I hope you guys are doing fabulous. Hi Sabha. And welcome all the new members to our lovely family. We are all warriors and I'm your captain, I'm your Thalaiva. And I'm going to make sure that you guys are always going to rise in life. I'm going to make sure that you guys are going to become really great engineers in the years to come. And you will always remember this channel, I hope, in the days to come, which would be a stepping stone, in your career. So this is a very special channel, English channel for all of you, and a lot of channels out there are there which are very good and they are in English or Hindi. So we wanted to do this for all of you, and I'm really glad that you guys are here and you made this channel grow till 50,000. So welcome aboard. Good evening. I'm Shreyas, and if you want to know more about me, you can definitely follow me on my Instagram handle. That's Shreyas_Vedantu. And let me also show you the special timetable out there. All right. Windborne, every day you say the same thing. Wouldn't gliding be faster? I'm not sure what do you mean by that. Please explain. We didn't understand that. Hi, Sai Telugu. Yes, we reached 50k and that video was amazing, right? I loved it. I mean, just looking at the past memories, looking at the past videos, how we have grown. I mean, it's crazy. Yep, Ankit, correcto. Good evening, Jagdish. Hello. Arjun, hello Dhanush, hi Challenger Man, wow, what a name. Alright, hi Kanishka. Alright, let's log it. Oh, by the way, for all the 2021 aspirants, so here is a special class. So guys, usually I take my special classes on Saturday, so I'm thinking of shifting it to some other day because this is very important right now. So, a small change. There's going to be a bit SAT strategy session targeting 400 plus. Basically, if you get less than 400, it's as good as not getting into bits. You will know why. And we are going to talk about the cutoffs, the branches, the different colleges and what is their lifestyle and what kind of things are there inside the college campus, and also about the placements. All of this on Saturday. And tomorrow, do not forget to inform your juniors, 2 o'clock. It's going to be a big marathon session for covering all the backlogs of units and dimensions, vectors and 1D motion. That's a big session. And then on Friday, you have uniform, non-uniform motion in a plane. That's 2D motion. That's for the 11th kids. And in case you have missed any of my previous 2 classes, please watch the replays. Now let's get going. Yes, next week also you're going to have class. You're going to have the class even after that week also, Unknown Krish. Munaba, it's your dream college. I hope your dream comes true, man. Like really this year or whenever you are going to give next year. I mean, it would be really great. And don't worry, we are going to conduct big bits, mock test and all of that. Don't worry. Yes, UV, I am teaching class 11. I hope you saw the timetable. So tomorrow, in fact, I'm conducting this big session for you guys, 11th standard. And Friday also, that's another session. A lot of people have a lot of backlogs so far that. So every week we put up this schedule for all the 11th and 12th standard kids. So understand, once the 2021 batch is over, the frequency of the classes of 12th and 11th will obviously increase. Okay, so let's get going to our next part. Thank you, Vikram. You too are sweet, man. And thank you for giving me those cupcakes, and it is mouth-watering. I love it. Okay, so we know that charges affect other charges by electric field and they apply electric force. And we have seen that the force acting on a charge, all right, so the force acting on a charge is charge multiplied by the field. So this is the force is nothing but the charge multiplied by electric field. Now we want to discuss, this was done long time back. We want to discuss, can a magnetic field also apply some force? But before that, a quick recap of magnetic field. Remember, bar magnets, horseshoe magnets, or any current carrying wire can produce magnetic field around it, and I have given you the different properties of magnetic field, and just in case you do not have it written down anywhere, I have made a beautiful set of points which you should remember. So what are those points? These are very important things which you should know about magnetic field. You will see the behavior of electric and magnetic fields is very similar except for one point. See, the magnetic field lines you will see will always emerge from the north pole of any magnet, be it horseshoe, bar magnet or any other thing, and they will again merge back at the south pole. So there are the two poles of the magnet, they emerge from the north and you will see they will again merge back at the south pole. That's one of the simple properties. Now the next thing is the direction of the field lines inside the magnet is from the south pole to the north pole. This is little bit different. Understand. UV bacha, that is wrong. That is electric field. This is magnetic field. I hope you get that difference. This is completely different. Understand, this is magnetic field. All right, be careful what you are seeing, what you are hearing, what you are saying. All right, now understand, if you compare it with an electrical dipole, the electric dipole, the field lines used to emerge from positive and they used to terminate at the negative charge. That's how the electric field lines used to look like. And within that dipole, they used to start from positive and end at negative. Start at positive, end at negative. That was electric field. But look over here, inside the magnet, they continue moving from the south pole to the north pole, that is from minus to plus. So they are not ending there, they are continuing their motion. Be careful. I hope this is clear. This is very, very important. Nandini, join in, bacha. We have just started. Yes, tomorrow marathon class for 11th standard. Yep. All right. Next, you would now see the big difference from this point, and that is basically magnetic field lines. Exactly. Somebody already said that. PL. Very good. It forms closed loops. That means it never ends and never starts. There is no end or start to a magnetic field line, unlike for an electric field which always starts from positive and ends at negative, and in the worst case it can also start or end from the infinity. So understand, there is an end or start or origin to the electric field lines. There is nothing like that for magnetic field lines. They always continue their journey. That's why when they merge at south, they continue their journey from south to the north pole inside the magnet until again they diverge from the north pole. That's how it works. Good evening, Gomti. No problem, Vaishnavi, just join in. It's okay. We have just started. Good evening, Raju. Welcome aboard. Yes, Windboon, B is continuous. E is not. Correct, Saba. In dipole, it is from minus to plus. Correcto. Beautiful, guys. You guys are thinking a lot. Next important thing, and this is common in electric field also. Magnetic field lines will obviously not intersect with each other. They might come close, they might go away, but they will never intersect each other. And the last thing is the strength of the field depends on their closeness. Like over here, they are very close, so the field is strong. As you go far away, the lines separate out from each other, and hence you will see the strength is less. In fact, when I explained to you solenoid yesterday, I showed you how the field lines were cramped inside the solenoid and the field was uniform, but outside they spread everywhere and the field was negligible because the density was very less. So all these are very important pointers. Some of them are similar to electric field. These two are different from the electric field, like you can see. Okay. Let's get going to a simple question. Let's see how many of you get this. More than one option might be correct. Which of the following patterns given below are not valid magnetic field lines? Which of the following patterns given below are not valid magnetic field lines? So Ankit, because they emerge from the poles, that's how poles are defined. North pole is the point where they emerge from, or rather they diverge from. That's why it's strong over there, and at the south pole they converge back. That's why again it becomes stronger. Okay, that's how it works. Very good. Come on, all my warriors. Okay, a lot of you are saying A, some of you are saying A, B and E, some of you are just saying A and B. interesting. Some of you just saying B out there. The answer for this lies from the previous slide. If you have listened to the theory very carefully, you will get it. Guys, the answer is A, B and E. All three of them. Very good, Ankit. Very good. Some of you were saying windbone. Yes, excelente. Correct. Yes, magnetic monopole cannot exist. So guys, understand, magnetic field lines cannot originate from a point. They cannot terminate at a point. And also, this is not correct. They are starting from a point and they are ending at a point. This is true for a dipole. This is an electrical dipole. This is not true for a magnetic system. So this is electric dipole. I just drew it some time back. So if you place a positive charge here and a negative charge here, this works. This works for a positive charge. This works for a negative charge. This, yeah, it's a closed loop. This, closed loop. Yes, this works for magnetism. So the question was, which are not valid? So A, B and E. This is very interesting. Yep. Now, yep, Vikram. In fact, that's what I was coming to. Understand, in electricity, in electrostatics, you can have a positive charge, you can have a negative charge. These are electrical poles or electrical, charges which are separate. But in magnetism, understand, though we call this as north and south, technically speaking, you can never get only north or only south. That is never possible. Even if somebody tries to break that magnet into two parts, you are going to get a north here, a south here, and then from here you are going to get a north and a south. So wherever you broke, you are going to see at that point two new poles are there, south and north. So technically speaking, no matter how much you break it, you are never going to get two separate poles. You are always going to get it as a dipole. So you will see always in magnetism, north and south come together. One on one is free. Remember this line, buy one, get one free. This is the line which magnetism says. This is very, very important. I hope now you will never forget this. Very good. Says, everybody says, Clearo, amazing, oh guys. So remember this line for magnetism. Now, let's talk about the forces. But before that, let me make this important announcement about VIP, where you guys need to know that all those people who are getting themselves enrolled or planning to get themselves enrolled into Vedantu, we guys are giving you this one chance. We are giving you this promise that your scores will improve. And VIP is all about Vedantu promising you that your scores will improve when you are regular in our classes, which is something which no other coaching is delivering right now. And if you do not improve, your fees are returned back. And the reason why we are so confident about it is because of our results. Because our results are so amazing. Like the students who study in Vedantu are 6 to 7 times higher probable to get a rank in JEE Advanced and clear JEE Advanced and get into IIT. Or even for CBSE examinations, board examinations, you can see the rate is 5 to 6 times higher than the normal students who do not take up coaching or study somewhere else. So guys, with all of this, the batches are going to start very soon. In fact, there is one batch which just started on 28th of June. There is another batch starting up again. So remember, whatever package you take, you are always in the same batch. Understand, all these things are same. The only difference is whether you want a doubt solving or personal mentor. You can check out everything down below. Using my coupon code SHHPRO, you get 10% off. All right. So let's get going to the actual concept which we are going to learn today, and that is force on a charge which is placed in a magnetic field. So does an electric charge experience magnetic force? Asked Pandu. Yes, the answer is yes. And let's take up different scenarios and figure out what is the force. So I'm taking up different scenarios. and understand this. First, if you have a charge stationary inside the magnetic field, if you have a charge stationary inside a magnetic field, it will not experience any force. Remember this. Hey, Munnabai, very true. Pandu will ask better doubts than you. And that's why we get Pandu. So that you can be like Pandu one day. Now, we are going to see the formula, but remember these cases. Stationary charge will not experience force. If you take that charge and throw it parallel or anti-parallel to the magnetic field, still you will not see any force. That's surprising. You are moving the charge, still you will not see any force even if you throw the charge parallel or anti-parallel to the magnetic field lines. Number 3, third scenario. Okay, so this was the second scenario, no force when you throw the charge parallel or anti-parallel to the magnetic field. Now this is very interesting, and this is what we are going to talk about very often. If you throw a charge perpendicular or at some other angle, you will see there is a force. In fact, if you throw a charge perpendicular to the magnetic field, you are going to see that the charge gets deflected in a particular fashion. The speed never changes. You can see how the force is trying to change the direction of the velocity. This looks to me like a centripetal force. This looks to me like gravitational force of the moon on the earth, or earth on the moon, and the moon trying to go around the earth as if it's going in a circular path. Yeah, that's how it is. So guys, when you throw the charge perpendicular to the magnetic field, yes, you experience the force. In fact, even if you throw it at an angle, you will experience force. So you will see that the force on a charge which is moving is experienced only when the charge is moving at some angle. It should not be parallel or anti-parallel, or it should not be at rest. Now this is also very interesting. How do moving charges create magnetic field? Ankit, I would ask you a better question. How do stationary charges create electric field? Just think about it. So if a stationary charge can create electric field, why can't a moving charge create magnetic field? Think about it. Yeah. Now that's the formula. Nobody knows why. Abhi Mujes, I would ask you a better question. Why do two masses attract? If you have the answer for that, if you have the answer for why do two charges which are like repel, the answer for this previous question also is the answer for your question. Basically, understand, nobody knows why. It's just there. We take it for granted. Yes, it's true. No problem. That's how it is. Yeah. Now, whenever you change the sign of the charge which is moving, this is the velocity, this is the magnetic field, it experiences a force. If you change the sign, then the direction of the force also reverses. The direction, yes, it's a theory just by assumption, by observation rather. Not assumption, it's observation cycle. This is what we observe. Okay, fine, it works. Nobody knows why. Yeah. So sign of the charges changes, the force also changes. In fact, if you change direction of velocity and magnetic field both, if you change the direction of velocity and magnetic field both, invert it, then the direction of force remains same. But if you change only velocity's direction, if you flip it, then the force will flip. If you change only magnetic field's direction, then also you will see the force will flip. So this is how it works. Now, the formula for this is very simple. The force acting is given by Q V cross B. That's what the force is. Now that's the reason why if V was parallel or anti-parallel to B, then the force was 0. If Q changes the sign, obviously you will see F goes from positive to negative. It will also flip the sign. Matlab, if it was acting this way, it will now change the direction. And same way, if velocity or magnetic field both, any one of them change the sign, then force will also change the sign. And if both of them will change their sign, negative into negative will become positive. So then force will not change the sign. That's how it works. Okay, Rongala, don't worry, just join. You can also go back a little bit and you can watch the replay so that you do not miss any pointers that we have covered before this. Now, the most important thing out here is the force is always going to be perpendicular to V as well as B, because that's how cross product works. This force is perpendicular to velocity as well as magnetic field. That means there is no component of force along the velocity. There is no component of the force along the velocity. That means the speed won't change. The speed won't change. Now if the speed won't change, the change in the kinetic energy will be zero. If speed doesn't change, kinetic energy won't change, because speed, kinetic energy, come on, similar. Half mv square, direction doesn't matter, half mv square is kinetic energy. And by work kinetic energy theorem, if there is no change in kinetic energy, work done will also be zero. So understand, this force never does work. This will not change the speed, it will only change the direction. So that's what I have put over here for all of you. This force is perpendicular to velocity and magnetic field. It will never do work. It can only change the direction but not the speed. This is very, very important. Shall we now start doing some questions based on this? Okay, let's do some questions so that you guys get a little bit hang of this formula. Write it down. F is Q, V cross B. Okay, let's do this question. Let's fill in the table. Now there are different charges: electron, proton, electron, proton, electron, proton, thrown inside a magnetic field. This crosses represent the magnetic field is inside the plane of the board. Okay, everybody is going to use the right hand. They are going to need the right hand for solving this question. We have to figure out what's the direction of force on every single particle out here. 1, 2, 3, 4, 5, 6. Let's do this. Come on, my warriors. Let's start with particle number 1. Where is particle number 1 going to move? Okay, it's going to move here. Magnetic field, that's inside. What is the force? F is Q, V cross B. Velocity is there. Okay, magnetic field is inside. V cross B. Just turn your hands. V cross B. Where is your thumb going? It's going up. So that's the force. So it's going to be upwards. Very good. Second one. No, Munawai, don't use left hand rule and confuse yourself. No, don't use that. Okay, please, because in the examination hall, you're bound to make silly mistakes. Then, oh, but that's an electron. That's the catch. That's an electron. That means this value of Q will be negative. That means whatever answer you get over here should be negated, and hence it will be downwards. Yes. And next one, Q, this one is positive. So V cross B will be upwards. Q is positive. So second one will be upwards. I hope this is clear. So you need to be careful about the negative signs. Third one, it's a negative charge. Let's worry about it later on. Velocity is up. Magnetic field is inside. Velocity is up. Magnetic field is inside. So I think when you do V cross B, thumb comes left way. But that being negative, understand the force is towards the right side. Very good. Similarly, fourth one, understand velocity is left side. So you need to really hold your hand like this. See how I'm holding. My elbow is here, my arm is over here, my hand is like this. Velocity is there, magnetic field is inside. Velocity left, magnetic field inside. See where my thumb is going? It's going down. It's going down, and that's a positive charge. So that's going to be downwards. I hope this is clear. Okay, velocity cross B, that's going to be downwards. Be careful. Yep. And similarly for that electron, it's going to be exactly opposite, because the Q will be making it negative, so it will be upwards. Be careful, guys. Similarly for the last charge, sixth one, velocity is down. So see how am I extending the hand? I'm keeping my hand straight and I am keeping my right hand like this. Okay, I'm assuming as if I'm a student, and velocity is down and magnetic field is there. So magnetic field is there. See where my thumb is going. My thumb is going towards the right side. So hence for the sixth answer, it should be this way, right side. Oh my God. Windbone's hand is RIP. Very good. Pothan Rama. My God. I mentioned your name, man. I would be more happy to tell your name or take your name if you answer the questions. Just don't ask me to take your name. Okay? Come on. Very good. Alright. So guys, nice exercise. PT exercise. We did a lot of exercise with your right hand. So I think somebody was asking, sir, can we do left hand exercise also? Now code setup, don't do left hand rule. Don't do that. Please. Spain without S. Very true. Motion of a charged particle in perpendicular magnetic field. Well, now this is something which we need to do. See guys, if you throw a charged particle inside the magnetic field and it is perpendicular, this is very important, QV cross B, QV cross B, and it's clearly mentioned V is perpendicular to B, but even the force is perpendicular to velocity, you're going to see the speed magnitude will be constant, only direction will change, and this clearly tells me it should be a path which is uniform circular motion. It's going to be uniform circular motion. Understand that. Nothing else. Is that clear, everyone? It cannot be anything else because speed is constant. Force perpendicular to velocity. When is it? Obviously uniform circular motion. You have seen that centripetal force is acting perpendicular to the velocity. Hence, you will see that the particle goes in a circular path. Yes. Oh my God, Diamond Gamer. Please stop, man. Oh my God. Yeah. Chalo, let's get going. Okay. Now, let's figure out two important formula which you should remember for this scenario, that is the radius and the time period. So if a particle is thrown inside a magnetic field perpendicular to it, you can see velocity is there, magnetic field is inside. So velocity and magnetic field are perpendicular to each other. So in such a case, I can say since the motion is uniform circular motion, and therefore the force due to magnetic field will be mass into centripetal acceleration. What's that force? It's Q V B sine 90. Why sine 90? Velocity is there, magnetic field is there, angle is 90 degrees. Or is equal to mass into acceleration towards the center. Remember, it will have centripetal acceleration as it goes around it, and this will be V square divided by R. Now you just rearrange this, one of the V's will get cancelled, sine 90 is 1, R will be equal to, think about it, M, one of the V's remain, Q and B will go down, so QB. Now this is something which you are supposed to remember. Do not sit and derive it in the exam, because a lot of questions come on this radius formula. R is equal to mv by qb. Alright. Yeah. Next up, once you know the radius formula, you should also know the time period formula. Now, since it's a uniform circular motion, the time period of revolution, time will be circumference, the circumference divided by the speed. Now, what's the circumference? It's 2 pi r. Speed, what is the speed? Well, that's v. So just substitute everything, 2 pi by v into r. What is r? It's mv by qb. V and v cancel. So therefore, time period will be 2 pi m divided by qb. That's the time period for completing one circular motion. Remember this again, that's why I'm blocking this formula. Yes, Erwin Prince, you can do that. Definitely you can do that. Sir, what will be the path of a charged particle moving inside? That will be a circular motion. Remember, this is the motion is uniform circular motion. Remember, I just told you, Ankit. Okay. Well, where is Kirito? I cannot see Kirito. I don't know where is Kirito though. All right, cool. So now I have an interesting thing to you. Let's say you take a charged particle. Let's say you take a charged particle, throw it slowly and take the same particle. Now next time you throw it really fast. If you throw it really fast, what do you think will happen to the radius? Will the radius increase or will the radius decrease? Think about it. Yes, Erwin Prince, you can definitely use my coupon code for NEET Pro subscription as well. It will work for both. What do you think will happen? Yes, the radius will increase because V increases, radius will also increase. So it will go in a big circle. What if you take that particle, you are throwing it slowly, now you are throwing it really fast. What will be the time period of revolution? Will it increase or will it decrease? If you throw it really fast, inside that magnetic field, will the time period increase or will it decrease? That's going to be interesting question. Well, a lot of you are saying increase, some of you are saying decrease. Vikram saying no change, PL saying no change. Yes, Windbone, correcto Shruti, excellent. It will not change because it is independent of the speed. You might think, sir, it is going on a large circle more time. Yes, it is compensated by the large speed. Big distance, but also big speed. So it compensates, the time period does not change. Keep that in mind. Very interesting fact to see here. Okay, so all the derivations has been put down here so that when you download the PDF, you can see all the derivations again. Now, let's get going to a question coming up on your screen. Here it is. Two charged particles, M and N, enter a space of uniform magnetic field with velocities perpendicular to the magnetic field. So, two particles are there, one is M, one is N. You can see their paths are different. You can see that very clearly. The possible reason is, only one option is correct. Think about it. Anubhav Sarma, 1 second. Everybody is asking for the date. Just 1 second. Let me just call up Ramesh Pokhriyal sir. Just 1 second. Just let me dial and ask for the date. Hello, Ramesh Pokhriyal sir. Yes, a lot of Enthuse students are asking when is the date? Yeah, the JEE Main's date. They're all waiting. Acha, not yet decided. तो क्या बोलूं बच्चों को? What should I say? To wait. Okay. And meanwhile, but they're asking me every day, man. Please help me. Just declare it off. I mean, just give some date. July? Because last time I told these students that the date will be in July. So can you just keep the exam in July? I mean, like, so that way my prediction will also come true. Oh yeah, you'll do that? Okay, thanks bro. Okay, cool. Yeah, so I think it's sorted guys, it's sorted. I just had a deal. Alright, cool. So what about this guys? Oh, A? Alright. No, most of you are wrong. Well, the correct answer is actually C. Now, I'll tell you how to do this question. See, the radius is different. The radius is different. Who has more radius? Accordingly, you solve the question. Remember the formula for radius is mv by qb. Whose radius is more? Obviously, this is a smaller circle. This is a big circle. This is big. This is small. I hope you can understand who is big and who is small. That should not be a problem. So, radius of n is more. That means this thing mv by qb for n is bigger than mv by qb for m. Now, once this is done, because their speeds are same, magnetic field is same, it's given two charged particles are entering the field with the same speed, let's say, and field is also same. So m by q is what needs to be compared. So m by q of n is more than m by q of m. Now flip it, then the inequality will also flip. That's how inequalities work. So m by q of, flip it, right? So q by m of n will be less than q by m of m. So you can see this quantity out here, this is called a specific charge. Specific charge means charge per unit mass. That's the meaning of that. So that is more for m as compared to n. That's how it works. All right. Okay, cool. That's how it works. So let's get going to the next question. A lot of you got this question wrong. Some of you are saying A. Well, A is definitely not the answer. Now this is a beautiful question. Let's see how to solve this. Oh yes, Paparazzo, definitely you know it. You know everything about Vedantu teachers. Okay, if a charge enters a field, but it is not complete, it is only there in this part, it's of length L. Then when it enters, what is the maximum time it can spend inside it? How much time can it loaf around inside this field? That's the first question. The second question is, what's the maximum width of the field so that it crosses the field region to the other side? That's the second part. Let's think about it slowly. Guys, what are the different possible ways the charge can actually perform its trajectory? One is, it performs, obviously it's going to go in a uniform circular path. So velocity is there, magnetic field is inside, V cross B is like this. So that means that force is going to change the direction of the velocity. That's going to turn it around. So one possibility is it goes like that. Second possibility is it goes like this. Third possibility, it goes like this. Are all these semicircles or not? Think about it. No, Windbone, be careful. That's not the answer. Is this not a semicircle? Think about it. Yes, is this not a semicircle? All of them are semicircles. Another possibility is it goes like that, but after this it will go in a straight line. You throw it with more speed, then it will go in straight line again. Why straight line? Because once outside the field, it will not experience any force. That's why straight line. So it might just perform an arc over here. So hence, the question, the first one, what's the maximum time it can spend? Obviously, this will be less time. This is less time. This is slightly more. This is the most time because here it just goes outside the field. For this scenario or this scenario, it's just going outside the field. So this is max time. I hope you guys get this. This is the important scenario, maximum time. And since this is a semicircle, obviously the time that it spends, the T max, will be complete time period by 2. Now time period was 2 pi m divided by QB. So therefore it's just going to be pi m by QB. That's the answer. Correct. That's it. Sriram, it's too early, bacha. Watch the 11th standard classes. Matlab, you can have fun and sit over here and watch it, but a lot of things are dependent on electrostatics and other things. Oh no, it's not 2 seconds. Okay. Sir, yeah. So will this matter? Will this length matter? Well, right now it doesn't matter. The time that spends is not dependent on the width of the magnetic field. You can clearly see that. Now, for it to cross the field, do you see these two people have crossed the field? Understand, if it is going like this, just touching the end of that magnetic field line, that's the last speed for which it stays inside the magnetic field. Anything slightly more than that, it goes outside. Anything slightly more, that means this should be the maximum width beyond which, you will see it will enter into the other side. So hence, for that width, can't you see that L is nothing but equal to the radius? And what is the radius? It is mv by qb. Hence, that's the answer. Correct. That's the width. Gandhi Mati, flash series is already over. Number 1. Number 2, on wave optics, that is also done. Please check the playlist, bacha. It's all there. You just have to search for it. Just search for it. It's already done. Wave optics is also done. And flash series is also completed. And Pathfinder series will be doing wave optics. Understand that. And there is a beautiful animation to show you this. Look at this beautiful simulation on how you can actually see this particle moving around. Look at that. See, observe it very, very carefully. It enters the magnetic field, it turns, there you go, and returns. This is how it performs the motion. Amazing. Very good, very good, very good. So let's get going to the question ahead of us. Now let's talk about, we have thrown the charges at perpendicular direction to the magnetic field. How about throwing it at an angle? Now when you throw a charge at an angle, there is a very interesting thing that will happen. Let's observe this. Let's observe this. Now in order to show you that, first let me draw a simple diagram. Here it is. Imagine this is the velocity. Imagine this is the magnetic field. Just let's take, it makes some angle. Remember, the force acting is always Q, V cross B. It can be also written down as Q, V, B sine theta, which can be also written down as Q, V perpendicular into B. Now what is this V perpendicular? That means if V makes an angle theta with magnetic field, this is that V sine theta component, which is V perpendicular. What about V parallel, which is V cos theta? The point over here that I want to make is that only this component gets affected, is affected by the force. That's very important. Only the force acts on the V perpendicular component. But this component remains constant. It is unaffected by the force. And we have seen this. If velocity is parallel or anti-parallel to magnetic field, there is no force acting on it. No, it's not going to be a projectile. Exactly. Hence, understand, just forget this for a moment. Just forget this V constant. If somebody observes from here, if somebody looks at it from here, what he is going to see is the magnetic field is inside. Okay, somebody is looking at it from this side. The magnetic field is here. It's going away from you. And there is this velocity, which is V perpendicular, like this. Think about it, the velocity perpendicular like this. And there is another component which is inside, but that's V parallel. Just forget this for a moment. Just don't talk about it now. What will this V perpendicular do? That V perpendicular will make sure that it will go in a circular path. Won't it perform a circular motion? In fact, a uniform motion, a uniform circular motion like this. That means when you see from here, you're going to see the particle going like that. But remember one more thing, that there is actually V parallel as well simultaneously. That means there is circular motion undoubtedly, but also there is this forward motion V cos theta which is happening. So that circular motion coupled with that translatory motion together, you are going to get a beautiful thing out here, and that's going to look like this. It's called helical helix. It's called as an helix. So this is the path of an helix in the direction of the magnetic field. That's a beautiful thing that is happening out here. So here is the thing. There are two components. One is the V sine theta. The other one, okay, so remember this was actually V and this was V cos theta, which I called it as V parallel. This one I called it as V perpendicular. The radius of the circle will be only dependent on this. Remember what was the formula? mv by qb. So for that circular path, that radius which will be there, which velocity will you consider? Only v sine theta. Understand? So only v sine theta will be there. That's the radius of the circle. Also, it will complete one complete revolution in a time of 2 pi m by qb. Standard formula, because it is anyways independent of velocity. So the time period will be anyways 2 pi m by qb. Devaralu, don't spam bacha, I read your comment, we'll see when to do it. But for now, just concentrate on the session. Okay. Now, one interesting parameter which you should note over here is after one revolution, the distance it moves in the field direction, that is called as the pitch. So this distance is called as the pitch. So what's a pitch? So pitch is nothing but the distance along the axis of helix in one revolution. So guys, think about the formula for the pitch. What is the speed in the direction of the pitch? Think about it. What is the speed in the direction of the pitch? Come on guys, answer the question. Obviously, in that pitch direction, the velocity is v cos theta. And remember, distance is velocity into time. Distance is velocity into time. This is velocity. What's the time? One revolution. That's basically t. So therefore, you will get v cos theta into 2 pi m by qb. That's the pitch of it. Very good, Pili. Very good, Shruti. Very good, Uncharted. Very good, Windbone. Excellent. Yes. Okay. So that's a different. Oh no, by the way, the pitch of units and dimensions also mean the same thing. When you rotate it once, how much does the micrometer move by? The motion is very similar. Imagine the circular scale of the micrometer. It moves one revolution. How much does it move by? It's exactly the same thing. Actually, it's not different. Understand that. Thank you, AP Prakash. Thank you so much. All right. So let's get going to the next part. I hope you have understood this. Now we are going to actually solve some questions on that. But before that, I wanted to show you this cool simulation of how that particle actually moves. Look at that. These green arrow marks are actually the lines, the magnetic field lines. And look at that, the particle is thrown at an angle. It goes beautifully in an helical path. This is how it is. Oh my God, Pili, you are in 10th standard and you are able to answer this. I'm really glad. Either I'm teaching too well or you are understanding really well, or both. I don't know. Okay, chalo, let's see the questions. By the way, the derivation, etc., everything which I wrote on the board is printed so that it's available for all of you. Okay, let's see how many of you can do this question very easily. An electron is launched with some speed in a uniform field. It is thrown at some angle. The velocity will return to its initial value in how much time? Okay, thank you, Billy. Yeah, come on, my warriors, think about this question. The velocity is thrown at an angle. It makes an angle with the magnetic field somewhere between 0 and 90 degrees. I don't know what. So after how much time do you think the velocity vector will come back to its original value? And that should be very, very simple. Windbone says A. What about others? Come on, think about it, my warriors. What is the time after which it returns back to its original value? Mani says B. Munna Bhai, MBBS says C. PL says A. Interesting. Ronit says A. Alrighty. So the correct answer is actually A. Be glad. And the reason is very simple. It's an helical path. So if it is completing one round, obviously, think about it. It is taking one revolution, and one revolution, the time period for one revolution is obviously 2 pi m by charge into B. That's it. Oh yes, pure scam. Very true. Very true. The angle depends. I mean, like, people will confuse. Oh, like, yeah, that's why the 0 and pi by 2 are given. It depends. Yes, let's mark that. And it looks big. A lot of people look at the length of the option. This looks weird, so this should be correct. Obviously, you'll lose marks. Okay, now let's look at this question. Okay, very good, Siddheshwar. Yes, Paparazzo, it's A. Alright. Now, this is another beautiful question. There is a proton which enters a magnetic field with some speed. At what angle should you throw it so that the pitch and the radius are equal? The pitch and the radius are equal. Let's think about it. So, oops, where is my pen? Yeah, there we go. This is my helical path. All right. So it starts here and it goes till here. So let's say this distance is nothing but my pitch, obviously, and you throw it with some velocity. We all know you can divide it into two components. This is v cos theta and the perpendicular one is v sin theta. That's how it works. Great. And obviously the magnetic field will be in this direction. Okay. Now, what is the formula for radius? What is the formula for radius? Well, it's mv sin theta by qb. For a helical path, the radius of that circle, understand, the radius of that circle is, just look at it from behind, you will see it going in a circular path. Only v perpendicular will matter. This is v perpendicular. So that's the radius. What's the formula for the pitch? Pitch is v cos theta, the horizontal velocity into the time period, which is 2 pi m by qb. Now, according to the given question, the radius and the pitch both are equal. So if both of them are given to be equal, these two terms should be same. So mv sin theta by qb is equal to v cos theta into 2 pi m divided by qb. Now cancel out m gone, v gone, q gone, pb gone. Alrighty, sine is here, cos is here, bring the cos down, sine by cos is tan theta. What's left over here is just 2 pi, nothing else. So theta should be equal to tan inverse of 2 pi. That's the answer. That's how you keep it. Oh no, it's not 45. Everything is not 45. Rohit, well, I feel that you should study current electricity. Not much of dependence, but the fact that the previous part depends on, magnetic field produced by current carrying wires, and the distribution might be needed sometimes. So you might need some basic knowledge. So yes, little bit of knowledge is needed, but other than that, you don't have to worry about it. Yes, but still you can have a brief idea, but not too much of dependence. Okay. The nurture class money is going to be tomorrow, 2 o'clock afternoon. It's a 5 to 6 hours class, marathon, revision of all the backlogs. Alright. So tan is not defined for 2 pi. PL, understand, tan of something is 2 pi. This is tan inverse of 6.28. That is defined. This is not an angle. Please understand that. Okay, be careful. Yep. Pradeep, there is a link below in the description box, or you can just contact me on my Instagram handle, Shreyas_Vedantu. I'll help you with the crash course. Okay, either ways. Or you comment after any one of the previous videos, my previous videos, you just go ahead and comment. I'll reply to that comment. Okay, anything. Yep. Yes, 5 to 6 hours. Yeah, you can read H.C. Verma. You can read through my notes. If you just glance through the formulas also, you'll probably understand, definitely. Money, I just told you na bachcha, tomorrow, 5 to 6 hours. So guys, I'm going to need a lot of energy. So please tell your juniors, Shreyas sir is covering all the backlogs tomorrow. He's going to stand here for you with some nice breaks. So be there. Because a lot of them, 11th standard, chota bachchas have missed so many classes. Now they need to cover up. Now they're thinking, yes, we can watch the recorded videos, but I just need some push. Somebody please tell me few things at least live. Just halka fulka revise kara do koi. So yes, I'm going to do that tomorrow. Okay. Now, here is the next thing. What if the electric field is in the direction of magnetic field? Two things together. Well, now that's exactly the Lorentz force, guys. Okay, when two things are together. When you have electric field as well as magnetic field, there are two forces, force due to electric field and force due to magnetic field. The force due to electric field will be charged into the field itself, and force due to magnetic field, Q V cross B, that's it. So that's the total force. There is nothing great about it. I mean, you can just remember both the forces will act simultaneously. Charge will experience electric field as well as force due to magnetic field. Now, think about this particular scenario. What will be this quantity? The force due to the magnetic field. Come on guys, answer in the chat box out there. Sarvesh Mehra, I have already covered this chapter in one shot in Zero to Hero series. Just watch the Zero to Hero series. Alright. Now this is a long-term batch, Sarvesh, so that's why we'll be doing it properly, nicely, not in one shot. And let me tell you, one shot is not always beneficial. When you have time, please observe, learn properly. So what's Zero to Hero, bacha? That will be helpful. Yes, this is zero because both of them are parallel to each other. This is there. Yes, this is there. And this is in fact a constant force. And because this is a constant force, that means this particle will have constant acceleration. So understand, in this particular scenario, this B did not, or rather did affect it. It did not affect the charge at all because there was nothing which it was doing. There was no force on it. So only the electric field was applying some force and it was accelerating constantly, uniformly, as if it was in a uniform electric field. Nothing happened. So this is one particular scenario. Now let's take some other scenario and look at this scenario. Electric field is from top to bottom, and in fact I have made it into a beautiful question. You take a charge and throw it. Obviously the charge will deflect. Obviously, because the electric field is going to apply some force on it. Now you want the charge not to deflect. You do not want it to deflect. So how will you orient the magnetic field so that the charge does not deflect and go in a straight line? Interesting. Come on, my warriors. Yes, Sarvesh, I know you would want a live class, but unfortunately I have just done it, bacha, so please watch the replay. Okay, so that will definitely be helpful, and you still have time. And I would say if you want little bit more in detail, then you can watch the flash series. I have covered it in 2 marathon sessions, this entire chapter. 2 marathon sessions I have conducted few months back. Okay, Windbone saying B, PL saying A. Come on, my warriors, think about it. What should be the correct answer? Where would you place the magnetic field so that the net force, I don't know, you think about it, but the charge does not get deflected. Taste of life. Abhi saying C, taste of life saying A, Billy saying B. Interestingo. Well, I'll tell you what, the answer is inside. Now I'll tell you why it is inside. Because of this electric field, which is downwards, the force due to electric field will be downwards. It's a positive charge. Q into E. Obviously, that will be the force. Since the word used here does not deflect, that means net force is 0. That means there is one more force cancelling this force. And where would that be? It should be upwards. So the force due to magnetic field is upwards. Now velocity is here, magnetic force is here, and this is Q V cross B. How would you get this vector? By crossing velocity with field. Where would the field be? Obviously it has to be inside, because V cross B will give you the thumb in that. Just place your thumb there. Make sure velocity is aligned with your 4 fingers. Obviously when it turns like this, that means inside. So that's where the magnetic field should be. Hence the option A is correct. Now, no, the magnetic field is not the diagram. The electric field is, I just told, positive to negative electric field lines, no problem. Now the thing is, Does it depend on the charge? What if this was not a positive charge? What if it was a negative charge? Then what will be the answer? What if this was not a positive charge, this was a negative charge? Then where will the field be? Come on guys, answer the question. Oh my god, Saital, we are a little bit late, but it's okay. You can watch the replay even in the live class and catch up at 2x speed. Alright, PL saying B. What about others? Windbone saying still A. Uncharted saying outwards. I knew this. That's why I laid the trap for all of you and you just fell into the trap. Understand, even if it was a negative charge, still the answer will be A. It does not depend on the sign of charge. You're like, what the hell, sir? Sir, if sign of the charge will change, sir, force will also change. Correct. Exactly. The force due to the magnetic field will be down, but even the force due to electric field will be up. So it will anyways cancel. Both will change. Taste of life. Both have Q, do not forget. So even the black vector goes up, even the down vector goes down. This up vector goes down. Yeah, that's how it is. A lot of people make that mistake. Alright, very good. Venti didn't fall. Interesting. Oh, Windbone Venti, are you Kirito by any chance? Man, oh my god, don't tell me you are Kirito all this while. I probably realized it because you spoke in your third person. Yep, oh my god. Alright, that's the answer. Now let's deal with it. And basically these kind of fields are called as crossed fields. So cross field is when electric field is also there, magnetic field is also there, velocity is also there, and all three are perpendicular. That's why the word crossed field is used. So in crossed field you will see velocity is perpendicular to magnetic field, is perpendicular to velocity, electric field. And the force due to magnetic field, if by chance cancels the force due to electric field, then it goes undeflected. It goes undeflected and the velocity will be constant. And when that happens, QVB will be QE, and that's when the velocity is E by B. So only if the velocity is E by B or the field is adjusted according to other values, only then it will go undeflected. If any one of them changes, then you will see this will either deflect this way or it will deflect the other way. That's how it is. Alright. No, Arnav, I was teaching this TB last year, not this year. Okay, so that's how this is. Remember this formula, very, very important. Speed is electric field by magnetic field, very, very important. Okay, chalo, let's see how many of you can solve this question. Very good question coming up for all of you. And there is a particle which is thrown in both electric as well as magnetic field. It's not an easy question. Hello, Uma Maheshwari. And the question is, after what time will the speed of the particle become 2 times of V naught? Very good question. If somebody gets this right now, I'll be very, very happy. Really proud moment for that student who will solve this question, because this is a very good question. You throw a particle, electric field is there in x-axis, magnetic field is also there in x-axis. So if you want, I'll just draw the diagram. Okay. So you have the electric field like this. You also have the magnetic field in the same direction, and you have thrown the particle like this in the y-axis. So think about the motion, how it will be. I'll give you a hint. Think about it independently. Just think about magnetic field first and then think about electric field. Just think about their effects independently. If you look at it carefully, velocity is actually perpendicular to the magnetic field, and you know what should happen. And now analyze the situation and then take into consideration the effect of electric field. Trust me, it will be very easy. Windbone saying A, Taste of Life saying C. Interesting question. It's going to be very tricky, let me tell you that. It's going to be very, very interesting. Ram Charan also saying A. Okay, so lock your answers because we are going to discuss this in a very short while. Find the time after which the velocity becomes 2v0. Initial velocity is v0. Okay. Now, here is the thing. Understand this. When magnetic field is inside, velocity is here. Okay. Only because of the magnetic field, there will be a force. Just think about magnetic field. V cross B, it will be inside. V cross B, that is the force due to the magnetic field. Hence, if I look at the same diagram from here, from behind, what I'm going to see is the velocity vector is here, and we are going to see the magnetic field inside. This will be the magnetic field inside, and the force will be like this. The force due to magnetic field will be like this. So when I look at it from here behind, field is inside, velocity is there, force is this way. So that's how it looks. Now what will this particle do? Obviously it will go in a circular path. Obviously it will go in a circular path. And in a circular path, will the speed change? Think about it. Will this velocity change? No, right? It will always remain v0. This will be constant. This is uniform circular motion. So the velocity of the particle in that circular path will not change. The only thing that will happen, yes, velocity is in J, be careful. The only thing that will happen is because of the electric field. Remember, the electric field is inside too. The electric field is inside. So there will be a new velocity which will be coming inside, and that won't be affected by magnetic field. So as this particle moves, understand it always has that v0, but it additionally gets an x component, and this x component is not affected. It's not affected by magnetic field. It's only affected, in fact, this will only be affected because of this electric field. Think about it. Yes. Oh my God. Windbone, you need to increase your resolution, I guess. Yep. So only the electric field will affect. Why will magnetic field not affected? Remember, V cross B is 0. Vx cross B is 0. That's the reason. Because Vx cross magnetic field is 0. That's why there is no effect of the magnetic field on that. That's how it is. Is everybody clear to this point? Then we'll go ahead. Because we have not yet done anything as such equation wise. Cool. Everybody clear to this point? Okay. Now, let's see, after some time when the velocity will become 2v0, that means the resultant velocity is 2v0. And using Pythagoras, we know this, 2v0 square will be v0 square plus vx square. That's what it is. Now just move it to the other side. So you will get 4v0 square minus v0 square is equal to vx square. 4 minus 1 is 3, and take square roots, you will get root 3 times of v0. That's what I got. Vx is root 3 times of v0. But remember, vx is due to acceleration of the electric force. Acceleration of the electric force. That means I can use kinematic equation, and Vx is ux plus ax into t. If I use that, what is the initial velocity in the x-axis? That's 0. Initial velocity in the x-axis is 0. What's the acceleration in the x-axis? That's force divided by mass. Electric force is QE divided by mass is acceleration into time. What is Vx? Well, that's root 3 times of V0. Rearrange it, you will get time is equal to root 3 times V0 into m comes upstairs and Q and E go downstairs, which is, I think there was a 2 missing somewhere. Is there a 2 missing somewhere? Just check this out. Okay, I think this 2 shouldn't have in there. Yep, this 2 is wrong. Yep, this 2 is wrong. Yep, be careful. So I'll just edit it, don't worry. I'll just remove it from the slides because that should be the answer, guys. So this 2 has come extra. Let me see if I can remove it right away. Oh no, I can't. Okay, no worries. I'll make sure that the content team changes it. All right, don't worry. Vicky, you just need to go down. I'll tell you how to get to the crash course. Just 1 minute. So Jagdish, already we are taking sessions for 1 to 1.5 hours almost every day. And remember, if we take it too long, then probably it might take, not everybody will be able to grasp. So we are dividing into small parts, but not very small, that our class duration becomes very less. So we are not like other YouTube channels which take classes only for 30 or 40 minutes. We take it properly for 1 hour to 1 hour 20 minutes or 1 hour 30 minutes. So I think it's fine. Okay. So don't worry. It's fine. So this is the first homework question and this is your second homework question, which you need to put up the answers in the description box below. Now, when you actually see our videos, so some of you are asking how to join the crash course or the pro subscription. What you need to do is go below in the description box. You will see 2 links. There is one crash course. If you click on the crash course, you will see the link for joining the crash course. One batch which has just started this week, and other batch which has the starting days as 5th of July. It will have 20 test series and everything, doubt solving, time management, strategy sessions, everything. You have to use the coupon code SHCC so that I can be involved if any problem happens. Plus you get that 45% off. It's not 40%. So it's very important that you note this. Second important link for all of you is this pro subscription. And this is your long-term batch in Vedantu. And you will see that you can also change. If you want to change to CBSE batch or something else, you can change class 12th or even some CBSE or NEET. You can change to whatever grade you want to. It's up to you. Okay. And just 1 second. Okay. 1 second. Yep. So you just click on that link. Where did it go? Yep. So you can change the grade out there. You will have the long-term batch. Apart from that, what you're going to get is all these classes are live and they are 2-way, and there will be a class teacher inside it to solve all your doubts. So doubt solving during the class by a class teacher. You will get assignments after every class. You will get the PDF notes, so you don't have to actually sit and make notes. You'll also get test series. So every 2-3 weeks there is a test and a detailed report card for that. Also, if you want a personal mentor or doubt solving after it, then you need to go for the classic version or the plus version, because that will have all the features. Now these prices are really affordable. Like you can see, for the classic version, it's like 45 grand, and that's for the entire year, and you can get it for 3,825 per month, and you can even try it out. You can just enter your details, you can try it out, use this code so that you can at least save 10% on the price. And these are really throwaway prices, because the kind of offerings you are getting, I mean the doubt solving, the assignments, the notes, the test series. Not just that, let me tell you, there are other courses, revision courses, and this course will run till next year end. You don't have to pay 1 single penny for anything else, be it Olympiad, be it boards, be it KVPY or anything. So everything is comprehensive of this course. It's a very popular course, this, especially the classic one, because many people want the doubt solving also along with the regular classes. So check it out, guys, because even I am teaching in many of the micro courses. In fact, I have made many videos as well on that, on which are the micro courses which I am taking. So all of this at throwaway prices of hardly 3,000 rupees or 3,800 rupees per month, and you get 10% off only after you use the discount coupon code. Alright, so yes, Vicky, you are going to also have micro courses of mine. All you need to do is, if you want to check which micro courses are there of mine, I'll tell you. Just go to our channel, just go to videos and just go a little bit down. Okay, just few days back only I conducted one class. Okay, I don't know where it went. Yes, it is here. Look at this. Shreyas sir's courses on pro subscription revealed. So in this video, I have talked about all the courses that I have taken on the micro courses, and not just me, there are many teachers just like me who are taking these micro courses. All right, so that's what you need to do. Cool. So let's wind up this class. Thank you guys very much for being here, and I hope you enjoyed the session, and do not forget to smash the like button down there if you enjoyed it, and hit the subscribe button also. Take care guys. Tomorrow you're going to have the physics class, but that's for 11th standard. Remember, few days 11th, few days 12th, and there's no point just taking everyday physics for 12th. So you need to also take a break and also revise through the topics whichever I have taught. So tomorrow at 2 o'clock, tell it to your juniors. Shreyas sir will be there for almost 5 to 6 hours just taking a revision for their backlogs. Hasta la vista, this was Shreyas here.